Section 3, Measures of Average. In casual terms, average means the most typical case, or the center of the distribution. Measures of average are also called measures of central tendency and include mean, median, mode, and mid-range. Let's start with mean. The Greek letter sigma is used to represent the sum of a list of numbers. If we use the letter x to represent data values, then sigma x means to find the sum of all the data values in the set. The mean is the sum of the values in a dataset divided by the number of values. We let x bar represent the mean, so you would read this symbol as x bar. So to calculate the mean, if x1, x2, x sub 3 up through x sub n are the data values, then the mean, or x bar, is equal to the sum of x sub 1 plus x sub 2 all the way up to x sub n divided by n. Or using sigma notation, sigma x means add up all those data values from your set and then divide by the total number of values in your data set. For example, let's look at this list of numbers, which is 2, 3, 2, 21, 3, and 3. To calculate the mean of this, we need to add all these numbers together. And then we have 1, 2, 3, 4, 5, 6 data values, so I'll need to divide that by 6. Plugging this into your calculator, you get 34 divided by 6, which is approximately 5.67. So out of this list of numbers, we would say the mean, or the average, would be 5.67. When we look at these numbers, though, we notice that we have 2 2s, 3 3s, and then this really big number of 21. So if I had to guess, this big number is probably messing up our average, since most of our data is actually closer to 2 and 3, not quite almost 6. So this 21 being much larger than the rest of our data set definitely has an impact on our mean. So the mean can be swayed by large or small values if they're far away from the majority of your data. We call these values outliers. The median. The median of a data set is the value in the middle, if all the values are arranged in order. The median will either be a specific data value in the set or will fall between two values. So how do you find the median? Write the data values in orders from smallest to largest. You could also go from largest to smallest, it doesn't matter, just as long as they're going in order. Then, if the number of data values is odd, the median will be the value that's exactly in the middle of the list. But if the number of data values is even, the median is the mean of the two middle data values. Find the median of the same list of numbers. Well, let's start by writing them in order. So my smallest number I see is a 2, then I have some 3s, and then my largest number is 21. And I want to find which number is in the middle, so I'm just going to start canceling one from each side until I get to the middle. And in the middle I have 2 3s. Now it's going to be a little silly since our numbers are the same, but if these were different, or even if they are the same, you still want to find the average of these two numbers. So to do that, or to find the mean of those two numbers, you would add your values in the center together, ours just happen to be the same number, and then divide by 2 because there's 2 of them. So I would get 6 divided by 2, which is 3. So the median of this list of numbers is 3, which to me seems like a very good measure of the center if I were to ignore the 21. Again, that outlier messed up our mean a lot when we did it the first time because it kind of pulled our data to the right or to larger numbers. But for the median, we don't really care about our outliers that are on the far ends of our data because we only care about the actual center of our data. Let me just show you, if you were to have had some different numbers, like so let's say you had 1, 2, 5, 7, and we did the same thing to find the median, and again we have two numbers in the middle, you would follow the same process where you would add them together and then cut it in half, and we would see that the median in this case would have been 3.5. So it doesn't always happen to be the same number twice. That just is what happened in our example. You may have other examples where you have different numbers and you do the same process. If you had an odd number of data values and you wanted to find the median, what'll happen is you'll just be left with one number, and that will just be your median. You won't have to do any other math. Again, those were just some examples. The mode. The mode is the value that occurs the most often. And it's possible that you would have more than one mode or no mode. For our example, let's find the mode. So we have the numbers 2, 3, and 21. Now I did not have to write them in order, but if you do write them in order, if you have multiples of the same number, they'll be next to each other. So when I write them in order, it's pretty obvious that the number I have the most of are my 3's. So my mode for this data set is 3, which also matched what our median was. Now, your mode can also be found for categorical data. It doesn't just have to be numerical. The following data shows the number of undergraduate students for each major at UCR in 2019. Find the mode. So for mathematics, UCR currently has 451 undergraduate mathematics majors. They have 2,365 undergrad biology majors, 738 undergrad computer science majors, 1,677 undergraduate psychology majors, and 84 undergraduate music majors. And the mode still means whichever one occurs the most often. So the mode for this data set would be biology. Biology has the most students majoring. And lastly, let's talk about mid-range. So mid-range is another measure of central tendency, and it's calculated by finding the average of the highest and lowest value. So add the highest and lowest value together and divide by 2. So let's calculate the mid-range for the same list of numbers. Our lowest value is 2, and our highest value is 21. So we need to add these together and then divide by 2. And our mid-range comes back as 11.5. So you can see, based off the other measures of central tendency that we've calculated, the mean, the median, and the mode, that the mid-range, similarly to the mean, was very affected by this outlier of 21, right? Our average it gave us was 11.5, or our measure of the center, I should say, they gave us 11.5, when our other ones were a lot closer to 3. Our mode was 3, our median was 3, and even though our mean was a little bit high, 5.67 is still closer to 3 than it is to 11.5. So the mid-range is not always the best for calculating the center. It has an advantage, which is that it's very easy and quick to calculate because you just have to add the lowest and highest and divide by 2. But it also has some disadvantages. One of them being that it ignores most of your data values. It only considers the highest and the lowest, and it skips everything between them. So it's not a super reliable measure of central tendency. Finding the mean for grouped data. The procedure for finding the mean for grouped data. Step 1. First thing you need to do is find the midpoint of each class in the grouped data. Step 2, multiply the frequency for each class by the midpoint of that class. Step 3, add up all of the products from step 2. So add up all the numbers you got in this case. And then divide the sum of those products by the total number of frequencies, or the total number of data values. And that's what this notation is here. The mean of our grouped data is equal to the sum of the frequency times the midpoints divided by the total number of data values. Let's try to represent what's happening in this equation with a table. And hopefully you recognize this data. It's the same data we've been looking at for the high temperatures in the 50 states. And in section 2, we already calculated all of these midpoints. So I'm just going to go take that information that we did in the last section. All right, and these are the midpoints we calculated in section 2. According to our equation here, what we need to do is we need to multiply the frequency by the midpoint for each of our classes. If you multiply 3 times 102, you get 306. Multiply 8 times 107, you get 856. Why don't you take a second and pause the video and calculate the rest of this column. Once we have the frequency times the midpoint, this tells us to add all of those together. So let's add up this column. If you add up all of the values in this column, you should get back 5,715. So far we've calculated the numerator. This 5,715 is the sum of all of the frequency times the midpoints. But now we need to divide it by the total number of frequencies, which we can get by adding up this column. So let's take 5,715 and divide that by 50, and this gives back 114.3. So what does this number represent? Well, this is the mean for our grouped data, and our grouped data was talking about record high temperatures for the 50 states. So what this number is saying is the mean state record high temperature is about 114.3 degrees. Let's talk about what we were actually doing here. This information that we were given, so the classes and the frequencies, is just to give us an idea of how many states recorded a high temperature within these ranges. Right, so 3 states had a temperature somewhere between 100 and 104. But we don't know what that temperature was. Maybe they were all 100s, or maybe it was a 100, a 103, and a 104, or maybe a 102, a 102, and a 104. Like, who knows what that actual temperature was if we were just given this part of the chart? So since I'm not entirely sure what those 3 temperatures were, I just take the midpoint of the range and assume that all 3 of them were this to get kind of an idea or an average. So maybe they weren't all 102, but they were close to 102. So instead I'm going to count 102 3 times. And if I added 102 plus 102 plus 102, I would get back 306. So it's kind of like I'm considering, as if I had known my data values, that those 3 states each recorded a temperature of 102. And then for my next one, I had 8 states that had a temperature somewhere in this range. Again, I don't know what the actual temperatures were based off what I was told here, so I'm just going to take the middle number, which is 107, and assume that all 8 of them recorded a temperature of 107. And I'm doing this for all of these categories. So for the next one, I'm going to assume that all 16 states recorded 112. And it's just supposed to get me close to what it might have actually been. So imagine that I had all this data actually written out with these approximations, and then I added them together. I would get back this number, and then I divided by the total number of data values. Isn't that exactly how we find mean when we actually have all the numbers? So we really are finding mean in the exact same way. We're just kind of making an educated guess by picking a number in the middle of our range to get close to what we think the actual temperatures recorded may have been. All right, and we have a chart in our packet comparing the measures of average, so some strengths and weaknesses of each of them. For the mean, some strengths are that it's unique and there is exactly one mean for your data set. It considers all of the values in your set, and it's pretty easy to understand that it's a measure of the average number of all the numbers you were given. A weakness of the mean is that it can be adversely affected by one or two unusually high or low values. So in the example we did, we had that 21, which definitely made our mean a little bit higher than it probably would have been if all of our values were actually closer to the 2s and 3s. And if you have a lot of data, it can be very time consuming to calculate your mean. The median. A strength of the median is that it divides your data set neatly into two groups, and it's not really affected by extreme values since we don't really pay attention to the ends of our data set. But that's also a weakness because you can ignore the effects of your large or small values, even when they are important to consider. Your mode. A strength of the mode is that it's very easy to find. It's just the one you see the most often. That also means it describes the most typical case, and we can use it with both numerical and categorical data. A weakness is that there may not be a mode. Maybe none of your values are ever repeated. It also may not be unique, meaning that certain values may be repeated the same number of times, so there's more than one mode. And it can be very different from the mean and median if the most typical case happens to be near the low or high end of the range. And lastly, the mid-range. Strength of the mid-range is that it's very quick and easy to compute, and it provides a very simple look at the average. However, a weakness is that it's dramatically affected by extremely high or low values in the dataset, like we saw with the 21. And it ignores all but two data values. It only looks at the lowest and the highest.